We are on part 2 of chapter 5. And in the previous section under TCP/IP configuration, we saw that each computer must be issued an IP address. We configure the subnet mask and we configure the default gateway. The three key variables to configure are IP address, subnet mask, and default gateway. We will talk about DNS later. So after all the computers are configured with IP addresses, we want to see if they can talk to each other. So we use two utilities to allow us to do that: the ipconfig command and the ping command. The ipconfig command shows you your current configuration, and the ping command determines whether or not you can communicate with another computer. If I go to the command prompt and I want to see what the IP address is of this computer, and I type ipconfig and press enter, I can see that the IP address of this computer is 10.20.12.206. There's the subnet mask, and there is the default gateway. Now, if I get all zeros here, then I know something's wrong. But what I do know now is this computer has an IP address. And then the ping command is used to try to send a signal out to another computer to see if that signal, if the other computer will reply to the signal. So if I want to see if I can communicate with another computer, I type the ping command. If I want to see if I can communicate with computer 10.20.12.206, I type ping followed by the IP address and press the enter key. And I see that I do get a reply from that computer. So what this tells me is that that other computer is up and running, and all the cables between me and that other computer are properly functioning. Now let's look at troubleshooting using ping, and we see that we can troubleshoot using a process of elimination. So here's the situation. The user says that he can't log on to server 1, which is on another subnet. So we got to figure out if the problem is the workstation, or is it the router, or is it the server on the other end. So here's what we do. We tell him to step aside, and we step in there. And first, we use the ping command to just see if we can ping ourselves. So we stand at workstation 10.0.0.4, and we type ping 10.0.0.4, and we would expect to get a response, because you would expect you can ping yourself. Now, if you can't even ping yourself, well, then something is wrong with this workstation. You might have to check your IP configuration if you can't even ping yourself. Now, a shortcut way of pinging yourself, instead of pinging by the current IP address, if you just type ping 127.0.0.1, that means ping myself. It just saves you the trouble of typing in whatever the IP address is. This is called local loopback or self-test, 127.0.0.1. So, step 1, you see if you can ping yourself. If you can ping yourself, then the next thing to do is to try to ping your neighbor. You try to ping your neighbor. If you cannot ping the neighbor, then could be a cable break. If you can ping the neighbor, then you know you have a good cable connection. Then the next thing to do is to try to ping the near side of the router. If you cannot ping the near side of the router, could be that the cable fell out of the router, or maybe the router is not turned on. If you can ping the near side of the router, then you know you have a good cable connection to the router and that the router is up and running. Then the next thing to do is to try to ping the far side of the router. If you cannot ping the far side of the router, then that implies that the router is up and running, but the router is not properly pushing the packets through. In other words, the router itself is misconfigured. If you can ping the far side of the router, then not only do you know that the router is up and running, but you also know that it is pushing packets through to the other side. Then you see if you can ping another computer which is on the same network as the server that the user cannot get to. If you can ping that computer, well, then you know there's a good cable connection to the router. If you cannot ping that computer, that implies that there is a cable break somewhere. If we can ping this computer, then we know the cable is good going to the router. Then the last thing to do would be to try to ping server 1. If we can ping the computer right next to server 1, but we cannot ping server 1, that implies that server 1 is just not turned on, or maybe there's a cable break. Cable came out of the back of server 1. Maybe it's a bad network interface card. We've troubleshot the problem all the way down to server 1. Now, what if we can ping server 1? Well, then it means it's not a TCP/IP problem, it's not a card problem, it's not a cabling problem, it's not a routing problem. Most likely the user just forgot his password. So we can use ping using a systematic process of elimination to figure out whether the problem is the workstation, or whether it's the router, or whether it is the computer on the remote network. TCP/IP addressing guidelines, we've already discussed them. All PCs on the same network should have different host IDs, right? .2, .3, .4. The same network ID, so 10, 10, 10. And of course, all the same subnet mask. And no two networks should have the same network ID. We've discussed that. And then a couple other rules. The network ID and host ID cannot be all zeros. So you wouldn't have a network which is network 0.0.0.0. Furthermore, the host ID and the network ID cannot all be 255.255.255.255. That's reserved for broadcasts and subnet masks. And of course, the host ID, don't assign that to any computer because that's the self-test or local loop back. So these are IP addressing guidelines. Let's now turn to page 226, the dynamic host configuration protocol. Static IP address assignment. Static IP address assignment means you walk around to each individual computer and you type in the IP address. You go to the first workstation, type in the IP address. Go to the second workstation, type in the IP address. Go to the third workstation and type in the IP address. And of course, the disadvantage of this is it's awfully labor intensive, and it's easy, especially when you're doing a lot of these, to give two computers the same IP address, and you know that's called duplicate IP addresses, and this is the error that you would get if two computers had the same IP address. So we want to make sure that doesn't happen. And when you're walking around to each computer and manually typing the IP address, we got 5,000 computers at CCBC, it's easy to accidentally give two computers the same IP address. So that's the statement of the problem. The solution is the dynamic host configuration protocol. With the dynamic host configuration protocol, you do not go around to each workstation and assign the first workstation an IP address, and assign the second workstation an IP address, and assign a third workstation to the IP address, an IP address. You don't walk around to each workstation to assign it an IP address. What you do is you install a DHCP server that has a group of IP addresses. And when a computer powers up, it sends a request to the DHCP server that says, give me an IP address, and the DHCP server issues an IP address to the workstation. when each computer powers up, it sends a signal to the DHCP server that says, give me an IP address, and the DHCP server pushes an IP address down to the workstation. And if the workstation doesn't get turned on, then an IP address is not pushed down. This is called the Dynamic Host Configuration Protocol, where you do not have to walk around to each workstation to issue it an IP address. In the DHCP protocol, a DHCP server has a group of IP addresses, and that group of IP addresses is called a scope. And a DHCP client is the computer which receives the IP address. It's usually a workstation, but it could be a printer or a server. So to configure a DHCP client, and when we say to configure a DHCP client, we mean to configure a computer to request an IP address from a DHCP server as soon as it's turned on. What we do is we go into the Ethernet connection properties, and under the Internet Protocol version 4, we select properties, and where it says enter the following IP address, we do not type in an IP address. We select the radio button that says obtain an IP address automatically. In fact, when you install Windows 7, this is what it defaults to anyway. And when this radio button is selected, then what happens is that when the workstation powers up, it sends a signal to the DHCP server requesting an IP address, and the DHCP server pushes the IP address back to the DHCP client. So in static IP address assignment, you have to manually walk up to each computer to issue an IP address. But with DHCP, the DHCP client requests an IP address, and the DHCP server issues the IP address. Page 227, automatic private IP addressing. The client requests an IP address from the DHCP server. DHCP server pushes it down. But what if the DHCP server goes down? Well, then the workstation is not going to be able to get an IP address. If the DHCP client cannot hit a DHCP server, it generates a temporary IP address, and this is called automatic private IP addressing. If the DHCP server fails and the client can't hit a DHCP server, then the workstation generates a temporary IP address of the following format: 169.254.x.y, whereby x and y are randomly generated numbers. The DHCP client cannot hit the DHCP server. It generates a temporary IP address of the format 169.254. Now, this IP address can only be used to communicate with other computers in the same network. It will not go through routers. It will not get you to the internet. So if you go to a workstation and you type ipconfig and you see 169.254.something.something, if you go to a workstation and you type ipconfig and you see an IP address of 169.254.something.something, then you know this is a DHCP client that could not hit a DHCP server. Now, every 5 minutes, it tries again to hit the DHCP server. Automatic private IP addressing just gives you a temporary IP address just to communicate with other computers in the local network, but certainly not internet access. So there are 3 methods by which a computer can receive an IP address. Manually, you or I could walk up to that computer and type in the IP address, and that's exactly what we do with very important servers. Or we could use DHCP to automatically push the IP addresses down to the workstations, And if DHCP didn't work, then automatic private IP addressing could be used to generate a temporary IP address. And this concludes part 2 of chapter 5, and in the next section we will move on to part 3.